Okay. Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Fany Dhiyaul Haq. My absent number is 78. And then I will discuss about sensor accuracy analysis on incubator analyzer to measure noise and airflow parameters. Okay, that is my name and my name number. Okay, next. Okay, this is overview. There are 6 points that I discussed about this material. And first is about the abstract, second is introduction, third material and method, fourth result, fifth discussion, and sixth conclusion. Okay, next presentation is abstract. In Fany incubator are equipment to maintain a stable body temperature for premature babies. Premature babies need room conditioning that is close to condition is the wall. Room condition is carried out in a baby incubator by providing a stable temperature, relative humidity, and measured airflow. The purpose of this study is to conduct further research on the incubator analyzer that focus on discussing the accuracy of noise and airflow sensor with the gold standard. In this study, an experiment was carried out for the sensitivity level of several sensors that had been treated by giving treatment to sensor to choose sensor with good sensitivity to be assembled into one in the incubator analyzer module. The built incubator analyzer module was also compared to the Fluke Inchu #2 gold standard for data analysis. The results showed that the analog sound sensor V2.2 had the highest error value at 32 degrees Celsius, and the D6F V03A1 had the ability to measure sensitivity, where the results were more accurate than the Inchu 2. Based on the error value on the noise sensor, the V2.2 sensor can be applied to measure noise in the baby incubator, and the D6F V0TA1 airflow sensor produce an accuracy of up to 3 digits behind the comma, which is more accurate than P standard module. Okay, and the next is introduction. The health and safety of newborn babies are of paramount importance to acceptance matter. This concern encompasses various potential issues and risks, such as the birth of a premature baby. According to the World Health Organization (WHO), an alarming 50 million babies are born prematurely each year, with over 1 million of them succumbing to complications related to premature birth. Newborn weighing 2,000 grams or less at birth, or stable newborn under 2,000 grams unable to receive kangaroo care, require a thermoneutral environment provided by either radiant heating or an incubator. An incubator or neonate incubator is a structured enclosure in which a baby can be kept in a controlled medical environment. G. Perez study concluded that airflow plays a crucial role in the care of premature infants. Virat Langsama's connect to a comprehensive study on infant incubator and lies in Thailand hospital, raising important question about whether physical parameters like sound, pressure, and temperature within the incubator align with international standards. The research holds significant value in investigating potential hearing loss in infants. The temperature is maintained between 35.5 degrees Celsius to 37 degrees Celsius, with a leakage rate of 1 degree Celsius from the outside temperature. Humidity at 70%, airflow of less than 5 meters per second, and the noise level inside the incubator of no more than 60 decibel. To address this, a monitoring tool was developed to track temperature, humidity, detect toxic gases, and monitor the baby's position within the incubator. Okay, this is a diagram block. You can see in my presentation also. Okay, this is input process and this output. Okay. Okay, next this flow chart. Okay, and then next. Okay, this is a material and method. Shows a diagram of auto research workflow. Sound sensor V2 in the airflow parameters. One sensor was used with the type of T6F V0T-A1. These sensors were treated to determine which sensor is close to standard result for each parameter. After the results were obtained, then the sensor with the best result was selected to be used in the incubator analyzer. In addition, the data can also be stored on the SD card. An infant incubator was measured using the incubator analyzer module with a standard incubator analyzer. The result obtained for the incubator analyzer module were then compared with the standard incubator analyzer so that the accuracy of incubator analyzer module can be determined. Figure 2 presents a flow chart of the process of measuring mean noise and airflow rate. At the beginning, the infant incubator was turned on and set at 32 degrees Celsius, so it will be raised for force. The infant incubator will experience an overshoot temperature and then it will decrease until the temperature on the display was reached and stable. This lasts about 1 hour or so. After it was achieved, then the data storage of noise and airflow rate were stored. Furthermore, measurements were also carried out at the setting temperature of 36 degrees Celsius through summer way, namely waiting for the temperature to be reached at and stable. Okay, next is the result. Okay, before that, you can see at the right of my presentation. This figure 2, there's the picture of incubator analyzer module top view. Okay, the sensor that have been selected will assemble in a box as shown below. In figure, you can see part of the research module. The humidity sensor function to detect humidity in the baby incubator, in which the sensor used was DHT22. T5 is a temperature sensor that functions to detect the temperature in the baby incubator, in which the sensor used was DS18B20. The airflow sensor was used to measure the amount of airflow in the baby incubator, in which the sensor used was the sensor from Omro with the type D6FV30A1. The noise sensor was used to detect sound or noise in the baby incubator, in which the sensor used was analog sound sensor V2.2 in the display section. It used Nexion TFT to display graph and sensor reading. In this case, the temperature is displayed in graph from to make it easier to know the overshoot and the stability of the measurement temperature. Okay, my next presentation is about discussion. The result showed that the proposed design can be used to measure the noise parameter and airflow rate in an infant incubator. The incubator analyzer module from this study consists of several sensors that were used to measure two parameters, namely analog sound, sensor V2.2 to detect noise, and D6F V03A1 to detect airflow rate in the baby incubator room. All parameters was displayed on the TFT screen in real time. Then the data will be saved on the SD card in CSV format. From module testing, the result were then compared the fluke into 2 to validate the measured parameter of the proposal model. The smallest error generated from the noise parameter was minus 2.3% at a temperature of 36 degrees Celsius, and the large error was minus 4.6% at temperature of 32 degrees Celsius. The airflow parameter was not calculated as an error because the InQ2 as a compression was only able to display a value of 0.1 milli per second. Or in other words, the research model was much more sensitive than the than it has not implied IoT, so it cannot monitor the result remotely. Then for the airflow sensor, that was also a difference in readings when the Arduino used a power source from the battery and power source from the laptop. Okay, and then based on this, it is necessary to make further consideration regarding the circuit and program selection for sensors. Okay, and then the conclusion is the purpose of this study is to conduct further research on the incubator analyzer that focus on discussing the accuracy of the noise and airflow parameter sensors against the gold standard. Based on the results that have been obtained when measuring overtaking data from the module and comparison tool, which is then carried out for data analysis, it can be concluded that based on the result of the noise sensor treatment of KW.037 and the analog sound sensor V2.2, this indicates that the analog sound sensor V2.2 is better than the KW037 noise sensor. When measuring using a comparison tool fluke into 2, the noise parameter has an average difference of 1.6 until 2.37 decibel, again a fluke into 2. The smallest error generated from the analog sound sensor V2.2 noise sensor is minus 2.3% at a temperature setting of 36 degrees Celsius, and the highest is minus 4.6% at a temperature setting of 32 degrees Celsius. This study can be used as a reference by other researchers who want to develop an incubator analyzer in the future. In addition, it is also recommended to use another type of airflow sensor which has a higher sensitivity and accuracy than the D6F V03A1. Okay, that's it. My presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.